They are now. Welcome back to the workshop. So today is going to be the final episode on stripping this S engine. In the last episode we got to the stage where we had taken out all the components and we'd given them a preliminary look, a bit of touchy-feely, you know, having a little look at it and seeing where it is. Now what I want to do is show you in a bit more detail how I measured the crankshaft, how I measured the Conrods, and how I measured the block to be sure of where we're starting from. With those measurements, I will then be able to make a much better assessment when I talk to the machine shop about the different things I want done. For example, the crankshaft has to go to be ground. That's a job that happens out of the workshop here because it's a very specialized piece of equipment. I want to know, roughly speaking, where the journals are now. Now, we did check this with the looking at the bearings, for example, but that tells me where the crankshaft was when the engine was last built. What I want to see now is how much more wear there is on that crankshaft and whether we can get away with a 10,000, a 20,000, 30, 40, whatever needs to be over grind on the big ends and the mains. So that's something that we have to do with the crank. We want to use the dial bore indicator in a few different ways to check the block, to check the Conrods, and also to check places like for ovulation in the bores. So we're checking the bores to see if they've changed shape or if there's any distortion. Once we have all those measurements, we can then, as I said, make a really good assessment of what we're going to do. We can pick out how much to overgrind the crank by, we can pick out how much to whether we need to line bore the main bearing journals, how much to grind off the crank pins, and whether the rods themselves will need work. Now, the really good thing is that we have another set of Conrods, so even if the ones we have are ovulated, we can check the other ones and see have we got a good matched set of four. A lot of the time in a situation where a customer brings me an excess amount of Conrods, I'll try and save machining by picking out if there was 4 good true Conrods, then there's no need to true up the ones that specifically came out of this engine. It would be just better to match a set that will suit. Now, there's more to matching Conrods than just measuring them to make sure there's no ovulation in it. We also want to match them by weight, but it is much easier for us to lighten and balance a Conrod than it is to line hone it to bring it into roundness. So if I can get rods that are naturally round, in other words the big ends are naturally round, I'd rather stick with that and bring them into balance with each other rather than just picking a Conrod that is the right shape, is the right weight but not the right shape. So the first order of operations is to get the micrometers out and measure the crank. The first measurement we need to check on the crankshaft is the main bearing journal diameters. This being a Cooper S crankshaft, we did find numbers on it, by the way, AEG 316, which confirms it is an S crank. The main bearing journals should be 2 inches in diameter, or in metric 50.81 to 50.83 would be the metric equivalent. Now, when we took this apart in the last video, we checked the bearing shells and it said it was on plus 20 thousandths oversize size. What I'd be expecting then to see is 50.3 or somewhere around that. So when you measure a crank pin, you need to measure it in 2 places. You need to, well, actually 3 places really. You need to measure it across the wearing surfaces. So if I show you one of these bearings, you'll see that there is a deep ridge all the way down the middle of the bearing. That ridge won't wear because it doesn't touch the crankshaft. It's only this side and this side that touches the crankshaft. So you need to measure both ridges. Your micrometer has this little clutch system here at the back, and that's to stop you from over tightening it. It's not a G-clamp, it's a micrometer, it's a measuring tool. So this is the right amount of torque. You should then check to make sure the micrometer passes completely over the pin. So what you're trying to allow for there is not measuring up high or not measuring down low. So when you've taken your setting distance, you want to make sure that you can easily pass the micrometer over the pin. So in this case, that's not what's happening. Just wanted to show you that. So some people might take their measurement here and then the micrometer simply won't pass down over the pin. So what you want to do is you want to get the anvils of the micrometer onto the center, and you want to come off, and then you want to come back on and come off. So you want to know that that passes completely over. We check that measurement, and what we see is we have 50.3 on that pin. If we check it this way, see what we have. So this is the 12 o'clock and 6 o'clock measurement. Again, checking that we can come off the pin and back on again. This is showing us that we've got 50.33. So there's different wear in this direction than in this direction. At 50.3 on that pin, we are right on the wear limit for clearance for a plus 20 thousandths grind over. I know that we're not getting away with that plus 20 thou, because when we come here onto this center pin where the wear is much worse, where we were seeing the coppering of the bearing, if we come onto here and check our measurement, we now have 50.25. At 50.25, we're well past the clearance or the running clearance that we could have on that center main bearing. There's no point in taking any more measurements on that pin now. It's worn. If you were right at the limit and you were thinking that you might get away with polishing it, again, you should do both sides. You should do that side, and you should do it at the 12 and 6 and the 3 and 9. 12 and 6 and then the 3 and 9. And you would do that on all of your pins. With a wear number showing me 50.25, I think I'm going to get away with an overgrind of going to plus 30, or grinding this pin in the minus. So going to a 30 thousandths. Now I'm sorry, I know I'm jumping between metric and imperial, and I know that's probably going to get some people's goat up, but unfortunately these machines were built in imperial and all our measuring equipment is in metric, so we're jumping a little bit between the two. A 30 thousandths oversized bearing requires a crank pin journal diameter of 41.28 to 41.29. We haven't seen anything like 49. We're still hitting above 30 here on all of these pins. I know the worst of the wear is on this one, and I'm still above 50.3 millimeters. So knowing that I'm above 50.3 millimeters, if I go to the next size overgrind, we said these bearings were on 20, and it is measuring up like they were on 20. If we go to the 30 thousandths overgrind, that means that the pin diameter is going to get reduced to 49 millimeters, well, 49 millimeters and change, and that's great because we have that in that pin to go. I've checked, Mini Spares have stock of 30 thousandths oversized bearings, so I can happily now go to my machinist and say, grind those main bearing journals on to the 49 millimeters measurement. So it's sorry, 41 millimeters, my apologies, 49.804. That's what I wanted to ground to, and that'll give us the highest or closest to the highest threshold, which is exactly what we want. This is a road going engine. We don't need any more clearance in the bearing. If it was a race engine, we might grind it to the lower end of the tolerance to allow it to be freer and smoother running. But in a road car, we're going to bring it to the highest clearance. So that's great. We've measured up the big end or the main bearing, and we know we are where we should be. Let's now check the big ends. These are the big ends for the Conrod Journals. Now, Cooper S would have a 1.6 inch bearing. We all know that one, or a lot of people know that one, which would translate in millimeters to 41 point, I think it's, where's my measurement? 41.28. So if we were measuring this and it was on standard, we would expect this to be around 41.2 and change. So again, the same thing, we're going to measure at the sort of 12 o'clock position. We're going onto the pin and back off again, onto the pin and back off again. And we're reading off our measurement. And the measurement we have here at the moment is 41.27 is what I get there, 41.27. So what that tells us is it is on standard, but it has wear. 41.28 was the minimum clearance allowed in the book figure. So that tells us that there is wear. Let's check this one and see. This one is even going to go a little bit more, I think. Yeah, 41.25 there. Let's check this one. Okay, so see that the mic doesn't want to go onto that one. I have to actually back the mic off. 41.26. And this is why I said to you, you check it in two directions. Now we're checking it at the 12 and 6. And we have 41.29. So if you only measured that crank pin at the 12 and 6 measurement, you would say, oh, that crank pin is perfect. It's exactly within tolerance. It's exactly within clearance. But if I bring the anvils around to the 3 and 9 o'clock position and test this, I now see 40.25. Way below clearance, meaning that that pin will need to be ground. So I'm going to go to the machine shop with this crank and I'm going to ask the machinist to grind the main bearing journals to plus 30 thousandths oversize. I'm going to ask him to take the big end pins to 10 thousandths oversize. And what that'll mean is that this crankshaft will be perfectly serviceable again. Questions arise about whether or not cranks start to get soft as you go past 30 thousandths of a regrind. And to be honest with you, in a race motor, I wouldn't be happy with a 30 thousandths regrind. I would send the crank to be nitrided, and then I would, I'd have it ground and nitrided if I had to go to that. Because this is a road going engine that will see very low mileage in what is going to be a restored car for shows, I'm perfectly happy to take this to plus 30 thousandths oversize, and it'll be perfectly fine on the mains. Good quality bearings, and we'll make sure we check our clearances properly and it will be perfectly fine. Incidentally, the primary gear bearing clearances should be checked as well. We know that the big side primary gear is the same size as the Cooper S crank pin, so it should be at 1.6 inches. And if we check that, again, on and off, this one is not so critical what orientation, because this is a full spinning bearing that will wear evenly all the way around. And the dimension I am getting there is 40.27 and the thickness of a line, so 40.27 and a half. That means that there is a slight amount of wear in this, but well within clearance. What we'll do is we'll polish this, we'll get the crankshaft grinder to polish this bearing surface for us. We will put a new bushing in the primary gear, but when we're turning the primary gear bushing on the lathe, we will allow for the wear that's going to be here by measuring this when it comes back from polishing and putting the right clearance in the primary gear, so that we get a primary gear fitting absolutely perfectly on this bearing journal diameter. Next clearance to check, we're happy with the crankshaft, is we're going to check the bearing journals, the main bearing journals of the block for ovulation. I'm just going to take one moment here to thank everybody who has donated so far to our coffee funding. We are shooting our first video on our new battery grip for the camera, which you guys have funded and allow us to buy. This battery grip has multiplied our timing from 40 minutes before we needed to charge our camera to 2 hours. So now we can be completely mobile and get 2 hours of continuous footage without needing to actually charge our camera. That's going to make a massive difference when we go to, say, the likes of the racetrack. That is one of the areas we want to film for you guys and do a sort of a vlog day in the life of me running motor racing cars. Having this battery grip, I know it sounds maybe a little bit simple to other people, but to us is amazing because we get 2 hours of continuous footage without needing to try and find a charging point or trying to find somewhere to get electricity to charge up our cameras, or else cutting our videos down and cutting the amount of content we can get for you guys to whatever our battery length is. We've also gone ahead and invested a little more into the channel ourselves, buying more gadgets. We've got ourselves the Rode mobile microphone. Now we already have the Rode here, that's what I'm recording today on, which allows me to just move and walk all the way around the workshop. But we have actually invested in the Rode 2, which is better quality lapel. It's also going to give us more, it also has better battery life, and having this one and the Rode 2 is going to allow us to do interviews with other people, which will be absolutely fantastic, and it'll give us again more higher quality content for you, hopefully better quality audio as well, so that you guys can hear the cars. One of the things we'd love to be able to do is get some sound of the exhaust and also some of the sound of the induction. With just one microphone, that's very difficult to do, but having two is going to make a massive difference to that. I'd also like to just take a moment to welcome any new subscribers to the channel, or in fact any new viewers. You are most welcome. Thank you for joining us here in my workshop and enjoying some of the content. Have a look around, there's loads of content building up on the channel now. See what you like, and if you like what you see, give us a subscribe. We really do appreciate it. To all my regular viewers, you are so welcome to the channel, and thank you so much for all of the input you've put so far. Please don't forget to hit that like button. As I said, it helps us grow, helps us to get to more people. More people means more content for you. So thank you very much to everybody who has, as I said, been on the channel and stuck through this far, and everybody who is new, as I said, you are most welcome. Let's get back to measuring up this engine. So the next thing to check is for ovulation in these main bearing caps. The measurement that these caps are supposed to be at, my memory is brutal, so I'm going to check it. I have it wrote down on the bench here, is 54.54 to 54.56. I have this set in the median at 54.55. We can check to see what our measurements are. So we bring the dial bore indicator in and we check to see what the highest number we get from the gauge. So if you can see the dial gauge now, it's rising up to the 0 and then falling away. So if that went past the 0, it would be telling us that that bearing is smaller than it should be. And if it didn't quite make it up to the 0, what that would be telling us is that that bearing has enlarged, it has stretched. When I say check for ovulation, what I mean is I was checking at 12 and 6, and I'm now going to check again, but this time I'm checking just shy of 3 and 9. So what I'm checking to see is, where is this going to go to? So just important to get the dial indicator just sitting exactly on center, and we see it coming up to 0 and then falling away again. So that's great, just slightly past it. So that's what I would expect to see. Now let's just check the far side of that cap and see if anything changes over there. Now, when you're checking this, you have to make sure that you're not on the actual split line. If you were on the actual split line, what would happen is you would pick up the change in surface. So again, that's great. It's going 100th past, which is perfectly fine, completely within tolerance. So that's lovely to see. That's telling us that this bearing cap is still completely in round. If it wasn't, we would have to either line bore it or line hone it. If it was maybe 0.3 or 0.4, we could take that out with a line hone. If it was anything more than sort of 0.04, by the way, and in millimeters, so 0.04, if it was any more than that, then it would be a case of having to skim these caps and line bore the block. I have actually checked all of the bearing caps. I did this on video just to show you, but I've actually gone ahead, I've torqued down all the bearing caps and I've checked them all, and they are all within 0.02. So plus or minus 0.02. I have the factory original BMC measurements and auto data for this, and the allowance, as I said, is between 54.54 and 54.56. We only have an indifference of 0.02. They're allowing an indifference of 0.03. Okay, so we're well within the factory tolerances here. There's no need whatsoever to line bore or line hone these caps. They're well within tolerance. I'm perfectly happy. I will, however, change these fasteners from this original Cooper S style fastener to the ARP fastener kit that MED sells, and I will recheck that again before committing finally to not line honing this. But I'm pretty confident, I've done this a few times, and I'm pretty confident I won't see any major change in these caps, but it will be diligent to do it. The worst thing we will see is a discrepancy enough that we need to line hone it, which means I can do that here in my own shop. It doesn't need to go out, so that's something we can do here. So it's not something I have to worry about before machining. The last thing I want to check is I want to check for any ovulation in these bores. And the reason I want to check that is because I know when we decide to liner this block, or if we decide to liner this block, we will have very little room to play with. If there is any ovulation or distortion gone into these bores, it could actually greatly affect our chances of being able to get a successful liner into this block. So let's get the dial indicator gauge set up for that, and I'll show you how to check for ovulation. I have my dial bore indicator here set up at 73.5 millimeters, which is what this bore should be, plus clearance obviously. And as I check here, the measurement I'm getting with clearance is 73.43 there, up here at the top. Let me see what we get there. 73.48. Check it at this dimension. 73.41. 73.41. Just check it here one more time. Right at the top here, I've cleaned off the carbon, and this is where there should be the least amount of bore wear, which should be what this was originally bored to, or very close to what it was originally bored to. And funny enough, it's bang on 73.5 is what I'm getting there. Just bang on 73.5. So that's what it was bored to, with a little bit of clearance for the rings. Sorry, a bit of running clearance. Generally speaking, 2 to 4 thousandths is what I'd expect running clearance, and this is pretty close to that. That's pretty much what I'm getting. The main thing that we're checking here is for ovulation. So we're looking for big changes between the top and bottom of the bore versus the sides. So if this block was distorted or had changed shape, what I would expect to see is different measurements at the top than at the bottom, or different measurements at the sides, top or bottom. Everything seems to be very true and round, which is good, because this engine looks like it has done a bit of work, but everything on it seems to be reasonably true. There's no massive distortion in the block. That's great. It gives us a lovely starting place. The plan is to bring this to the machine shop and see if we can liner it. If we can't liner it, we are in the position where, giving that bore dimension there, we could simply hone this bore. And in fact, if I was going to use a cast Omega, it will need quite a hone. It'll be right on the edge of what we can do with a hone. We may well have to actually consider running the boring head down through it. It'll be right on the edge if we wanted to use the cast Omega at the 4000 spore clearance. I really hope that I'm going to get the news that I want and I can put a liner in this. That's what we're hoping for. So fingers crossed on that. I'll let you guys know in future episodes what the state of this is. It'll be going, as I said, to the machine shop. In fact, to be honest with you, by the time this video airs, this will already have gone to the machine shop. So I'll let you know what the story is with that. I did say at the start of the video that I was going to show you me checking the Conrods for ovulation and size, but the video has already reached its time. So let's do a video specifically on Conrods, selecting and picking Conrods, and we'll do that in short order to make sure that you guys get the most out of it. There's nothing more for me to say on this episode, but see you guys on the next one.